Good afternoon, everybody, and thank you for the opportunity to present the AGS, or the St. Lawrence Fluorspar project. And I think it is a project that's been around for a while. Fluorspar has been mined in and around St. Lawrence since the late 1920s, early 1930s, so getting close onto 90 years. And when asked to present today, I thought that, instead of me presenting and putting everybody to sleep that's left in the room in 20 minutes, let's rather have you hear from the folks who are actually doing all of the wonderful work over the last year and get it straight from them. So as you know, the St. Lawrence operation and the AGS project is located on the southern end of the Buren Peninsula, just outside of St. Lawrence. As I said, long history of fluorspar mining in there in St. Lawrence. Various iterations of the project and proponents over the last 90 or so years. The AGS project and its previous operation that went through environmental assessment in 2016. Project got built and commissioned in 2018, and then in February of 2022, operations ceased. So after insolvency process and through a reverse vesting order, we acquired the project in June of last year. At the moment, Canada Fluorspar Inc. is wholly owned by Renova Capital, a private equity firm registered in the Netherlands. And just on the project itself, it really is a strategic project. I think it's not all that well understood or well known that it is the only commercially operational fluorspar mine in North America that produces acid-grade fluorspar, the only one. And it is one of a few fluorspar operations ex-China. To give you a sense for the global market, at the moment the merchant market is in and around 1.6 million tons of acid-grade spar per year, of which CFI produces or will produce 200,000 tons a year. And that's quite a significant piece of that merchant market outside of China. We currently at the reserve for AGS that we are in the final stages of preparing sits at around 7.1 million tons at a grade of roughly 20%. And the resource that we published earlier this year, which includes AGS, the Tefe deposit, and the deposit that used to be known as the Director deposit, is roughly 29 million tons at about 32% calf grade. And so when we start to think about that, we see a mine that has or an operation that has a life of mine of 24, 25 years. And that still excludes some of the underground operations, specifically AGS underground, but also the AGS North deposit and the Blue Beach South deposit, which was mined up until the early 90s. In addition to fluorspar, the other opportunity that we've started to really pursue heavily is the ability to utilize the granites and rhyolite waste rock to produce commercial aggregate for sale down the east coast of the US. It is quite a substantial opportunity, and based on early indications of the modeling, it potentially brings around 30% additional revenue into the project, and in addition to that, it significantly reduces the closure liability at the end of life of mine. So really a multi-generational project that we're looking at. Just in terms of the last year, some of the interesting statistics again is, coming out of insolvency, CFI had been left with 10 employees, 8 of which were on security duty. Today we are up to 223 employees and contractors. We're very much still in a construction phase, although we have started commissioning efforts in the mill and in the crushing circuit. Of the 223 employees, 81% of those employees are from the province, and roughly 51% of employees are from the Buren and live within a 50-kilometer radius of the mine. Now, that's one of the key strategies for us, is to develop a residential mine and to provide an economic base for the Buren. The other aspect we're quite proud of and what we've achieved in the last year is that from a procurement and contractor perspective, we have spent, since June of last year until the end of October, we've spent roughly $70 million, excluding the original acquisition price. Of the $70 million, 79% of that has been spent in the province, and about 14% of that has been spent on the Buren, specifically around Marystown, St. Lawrence, and Lawn. And that's something that we're very proud of. And I think the last thing to mention is that it's especially in the mining industries, it's something that gets spoken about quite a lot. But we are very proud of the fact to say that of our senior management team in St. Lawrence, 50% of those are women, and they, in general, just a fantastic team to work with. So just a little bit of detail around the project, and I'm sure the team will get into a lot more detail around geology, mining, and processing. But essentially, the AGS project is located on the western side of the Boot, and we at the moment focus on the open pit operations around the AGS pit, which in its previous iteration was seen or envisaged as 3 separate satellite pits. But we are also doing exploration work on some of the other veins, specifically this year on North and South Ridge, which used to be called the Director Deposit. That'll continue through June of next year, and we'll expand the exploration effort then into Tefe and into Blue Beach South, which we see quite a lot of underground potential for. It's also the only mine, Fluorspar mine, outside of China that has direct and immediate access to an export terminal through the Blue Beach facility. It's quite a big focus for the project as well, is bringing Blue Beach back online, and along with that, expanding that facility to cater for what will eventually be a 2.6 million ton per year aggregate facility. So with that, I'd like to introduce you to Melissa Lambert. I should say Melissa is a native of St. Lawrence, and 3 generations of CFI or St. Lawrence miners, I guess. So I'll hand it over to Melissa.
So as Eben mentioned, I am from St. Lawrence, very proud of it. Family has been there. My dad, my grandfathers have all worked in the mines there. One of the unique things is we have a major granite pluton that is the feeder source for all our mineralization in the area. And I know Eben touched on the early mines and stuff. Everything prior to our current AGS operation was based, all the mineralization was based in this granite source. So everybody thought, okay, we know what we're looking at, narrow vein in this, until 2013 when we put a drill hole up on a hill and managed to hit mineralization in different rock types, our metasedimentary rock, which opened up a whole new wide range of exploration. Previously, that was known as cutoff rock. Oh, we don't need to look any further. So this leads us into the geology of our AGS deposit, into the mine, and how we have multiple rock types, not only the actual rock type itself, but the difference in softness and hardness of each. Our fluorite mineralization is naturally soft. However, we have rhyolite, which is sourced from our granite, which has a high component of silica, a lot harder to blast, fragmentation's different. So that can be a little more complex when you're looking at how to mine it successfully. In addition to that, as the slide points out, we have our narrow veins being sourced and extruded into these vertical, subvertical fault structures. Not just one, multiple. So we're dealing with a really structurally complex ore body, and mining that successfully can be a little challenging. So how we decided to do this restart is start out doing a geotechnical program, mainly focused on your slope walls and stability. However, in that process, we wanted to do more controlled orientation drilling so we can really dial in our structural features. In addition to that, speaking from prior experience, I'd worked at CFI since 2014. We had some structural knowledge, obviously, and some geotechnical modeling done, but a real big focus of this past year was to get a really robust structural model, develop 3D models, mining rock mass model, and in addition to that, then we wanted to focus on doing a lot of acoustic and optical downhole surveys. We want to get the best picture we can to give us a really good shot of making sure that we're mining this successfully. In addition, as well, some of our past programs, obviously we're mining fluorspar. We're here for the calf too. But in addition to that, we have a lot of supplementary metal sulfides, zinc, and lead. And we just needed a broader suite of assaying, whereas prior we were mainly focused on the CAF2 and carbonate. However, knowing how these other minerals interact into our resource model is going to be a big help. So all of our assays going forward will be based on a broad spectrum and will be integrated into this resource model. And then in another thing, in previous as well, we had a few holes where we've done some packer testing and had an idea of what the water was doing down underground. But this geotechnical drilling program, we were successful in getting packer testing done on each hole, which will give us a better knowledge base of how we want to build our dewatering strategy. Once we shut down in receivership, it didn't take long for the pits to fill back up. So we're struggling with that now, just making sure that we can dewater that successfully. And it's not necessarily only from surface water runoff, it's also this underground groundwater component that we're dealing with. Okay, so here's just a little simplified local geology map. The pink represents the St. Lawrence granite pluton. All this historic mining was mostly been encompassed in that, and we're up here on this little tiny line. And it's also interesting to note that one of our other deposits that we have future exploration plans for is on that north side where you're seeing that lineament pop out there. Here's a side view here of just a drone shot of our current pits. You can see clearly, you can see the metasediment. This is that gray-brown kind of color, and then you get your rhyolite sills, which are the sourced from the granite below. They come up and break through this, but through it all, you see there's a little white cast in the middle. That's our ore vein. So subvertical can be difficult to mine. We need to make sure you mine it on proper flitches so that you don't get any dilution. So, going into that, our exploration previously, traditional drilling methods, we would get, some core boxes come back looking like this with sticks and breaks and no core recovery. And early days, we didn't put a lot of focus on the impact that this could have on a mining sense. So once we actually started active mining, we realized, well, this is going to be a big problem and we have to refocus and make sure that we analyze this properly. So this is something that was realized in pit. That's, my geo tool there. You can see a huge fault zone. So we're looking at a lot of fault gouge, With that, it's multiple components. You have some waste fault gouge, which would usually just haul off to overburden as waste material. But then you have a component where this structurally complex zone has been moving and grinding up all of this fluorite mineralizations that's with it. And we want to retain that. That's good ore. It's just difficult to process. So you need to make sure that you're actually mining this effectively. And I'm going to just jump back into this dewatering control. If you have a wet pit, this is something that we realized, that it makes this type of deposit and mineralization here really difficult to control and to mine. Once you start adding water, it retains moisture. It's really difficult to, first of all, drill the blast hole without it collapsing, and also once you blast it, how to keep and minimize the dilution of this finer material from entering the rest of your ore body and your good ore to the ROM. So this is some of the challenges that we're dealing with. We understand a lot more about it these days, and we want to make sure that we're mining that effectively. So this is just another, again, a little simplified diagram of our open pit design here, but it shows the general distribution of where we can kind of expect higher amounts of clays versus higher amounts of metals and carbonates, some of these refractory minerals that we do have to have challenges on the processing side. Perfect. And I will pass it over to Isaac. Thank you.
Okay, my name is Isaac Sam. I'm the mine manager of CFI, and I joined the mine, I think, this year. So I'm just going to take you through, some of the challenges. I think Melissa has done a lot in terms of the geology. So what I'm going to do here today is we'll look at the mining challenges that, the previous operators had, and, the new operators, the way forward or the path forward, how we are going to, address the whole, from geology, mining, as well as, processing. So if you look at the chart in there, you could see, first of all, as I said, Melissa has spoken about inadequate geotechnical drilling. No RC, grade control drilling was done. Ineffective dewatering, as well as water control. And you could see from the chart, it leads into more like, a suboptimal drill and blast design, because you don't have enough information to be able to, come up with a very good drill and blast design. And a very suboptimal, drill and blast design also leads into a poor wall stability, poor, blast fragmentation, which, doesn't align with the plant, because you realize from the processing part, when it comes to the DMS, it doesn't like, ultrafines, and at the end of the day too, it doesn't want rocks that are, very, very fragmented, right? And at the end of the day too, you don't want to have inadequate ore and waste, delineation. So inadequate information from the geology, from the geotech, dewatering, at the end of the day, you don't have control over all these stuff. Then once you have, poor fragmentation, it leads into low digger productivities, equipment wear and tear, ultrafine particles, because again, you'll not be able to predict your PSD curve to be able to come up and say, this is my top size and this is my minimum size. This is what my goal is to achieve when I'm doing drilling and blasting. And it leads to reduced crusher and mill throughput, ore loss and dilution, and overall, you lose cost, inadequate mine-to-mill reconciliation. And one big issue, too, was, inadequate stockpile management. So if you look at the ore, like when it comes to the Fluorspar, you need a very different approach when it comes to the stockpile management. It's not a usual stockpile where, you go into the various bins and you just dump high grade, low grade, mid grade, and that's it. You have to look at the geological body. You have to know the types of deleterious materials that you have, and you have to structure your stockpile management in such a way that at any point in time, whatever you are mining into the plant, you know the type of grade that you are putting into the plant. So we're going to go through the path forward, how we are going to approach, these challenges. So you can see this is a typical picture showing more like all the challenges, right? So you could see the all loss, dilution, poor fragmentation, water in the pit floor, and again, like it's I've mined various pits, right? This is not a very big pit, not a a huge operation, but you find all the challenges in this AGS pit. So you need a whole different technical approach when it comes to mining, and not the usual mining approach. So you see that this picture tells it all. Wall stability issues, you could see it. So what is the approach? So what we're looking at as a team is to go to like more of a mine to mill approach, which is been proven to yield results, right? And this is going to be the approach. First of all, we have the resource model. We're going to do a grade control model, and we also have the geotechnical model, which we've built more like a structural model, which will have all the rock mass classifications. And then from there, we'll develop various domains based on the plasticity or the BI index. And then we'll have in-house tools, which you'll be able to say, okay, based on this domain, what is the right bedding and spacing? What powder factor are we looking at? What is the crusher specification? What is the mill specification? Then it comes up with all these parameters. Then once you have this, we build it into another, a whole database model that whoever the drill and blast engineer is doing, once you come up with a block, you click on it, you load the blast, model, you'll be able to know, okay, this is the bedding and spacing that I'm supposed to use, and this is my specification, right? Then you come up with, the model will give you the PSD as well, and then you look at the cost, you estimate, what again, based on the whole value chain, what you want to achieve, and then you design, you do your fragmentation analysis, you fly drones to ensure that, okay, did everything go as well? And you do your productivity studies to understand, okay, what was my digger, productivity, what was my loader productivity, you check your flaws and everything. And you also go through the whole mill to, okay, how did the mill respond to whatever I put on the pad? Was it, did everything go as planned? And then it becomes a cycle. So it always, you're kind of building a side-based, model for, this approach to be able to, always ensure that kind of improve or optimize design for your mining. And one of that key thing too is, which is, again, is the usual, like you have to know where your oil is going, right? So one of the key things we are looking at is to be able to use, GPS fleet management systems to understand, our oil tracking. And one big issue that we also have is fog. So that is one other thing we trying to get, from the technology, members to see how best, we address when it's foggy. It can be very, very foggy, and we're looking at other technologies to ensure that, we mine and everyone that is within the operations is safe. So that is one approach for the oil tracking and safety. And Melissa talked about water management. So the approach that we're looking at is how do we ensure that we don't have, water coming, especially when it comes to surface water, coming into the pit. And since I joined, I've seen, once it rains, like it's so much water from the pit. So this is more like one of the, designs or the approach that we are doing, making sure that, we have, ditches in place, doing all the packer testing, getting sediment controls, everything in place, so that at the end of the day, we capture as much as, the surface water that will end up in the pit before it goes in there. And also when it comes to the groundwater, we're currently doing a lot of conductivity tests. Where can we position those groundwater, the watering wells to be able to get the water before they also get into the pit? Because there's a lot of fault zones. If you look at the structure that Melissa, showed previously, we had a whole lot of fault zones that we will have to look at and see how we can intercept those and get the water out of the pit. Because at the end of the day, you can come up with the best drill and blast plan. If there is water in the pit, you will not get the output that you require. And this is a simple, just showing the simple rampart management plan that, we're looking at implementing. So we'll have, high grade, medium, low grade, and deleterious, power, which, it will contain whether the clouds, high clay fines. And the whole approach is, okay, even with the high grade, we'll have two piles. And if you look at the direction, so the tracks will be dampened based on, the grade. So let's say if the grade is between 20%, fluorspar and above, whatever grade that is in the tracks dump, they don't, you don't dump everything together. So you dump in those piles. And then once you finish that whole line, the loader will pick it all across, so that you don't just pick from one end. Because what happens is, even though it's from 20 and above, you could have 40%, 20%. So to be able to, ensure a very steady, when it comes to grade to the plant, and to have that control, this is the approach that, we're looking at implementing when it comes to our rampart, management. Thank you.
Okay, I'll make this quick because I think everybody's hungry. And I know my audience, so I'm going to save you guys a little bit from my metallurgical mumbo jumbo. My name is Lena. I'm a process engineer by trade. And yeah, we're working on the process plant for CFI. So Isaac and Melissa talked a lot about, in terms of grade control and the amount of clays. And we talk about mine to mill. So why is it so detrimental? In terms of grade variation, Melissa touched upon it in terms of the silica, the granite, where our fluorspar is very soft. It's almost chalk-like. So when we actually do make it to our crushing circuit, the granite as well as metasediment actually does a better job of crushing the ore than our crushers. So we generate ultrafines. Then once we get to the plant, we put it into our mill. Again, we have metasediments making to our mill. Excellent material. Again, we generate minus 20 micron fines. That minus 20 micron fines is detrimental to our flotation process. It essentially interferes with the selectivity. And when we're making with such a high-grade product, we can't afford that, so we have to remove it. So that is one of our actually major recovery loss when we were in operation, and this is something that we're hoping to manage. And of course, we have a flotation circuit. They're not the most flexible circuits. When we have the DMS, it's able to take variation. Flotation circuit's not that case. So really being able to manage that in narrow vein mining, we just have to treat them well, and they will serve us well. The next one is the gouge material. We saw the voids. Part of the things that we saw in operation and is really these are, I guess in mining we would say ultrafines. In process plant, we'll say fines. We have our DMS, which is a huge shock absorber. It upgrades our material. It sends the best quality material to our plant. These material, however, bypasses the DMS. It's too fine. So that means we're diluting the grade to our mill, we're taking up tonnage in our mill, and we're essentially decreasing our process efficiency. And this is why we're so focused on controlling this going forward. And we really saw that when we were in operation previously. So a little bit of talk about what we're doing. We talked about there's a lot of mining activity, there's a lot of drilling. What do we do the rest of the project? A huge thing we looked at is really bringing a world-class asset to Newfoundland. And one of the things we looked at, which is one of our two major milestones, is the retaining wall. Our retaining wall used to be secant. It's probably very cost efficient, not great for longevity. So this is what we did. And it was completed this summer, actually sourced locally based on aggregate on site, crushed, and we completed that this summer. It looks beautiful. We're very excited to use it. The next project, probably a little more shocking. During receivership, our crushed ore dome, actually, the roof collapsed. Yeah, not great, but we're happy to present you guys our new crushed ore dome. It's ready to receive ore, and it looks beautiful. So, in terms of this, we looked at kind of the project, without the traditional waterfall project. We mine, we get fresh ore, then we commission the plant. at CFI, we've taken an alternative path to ramp. And what we're looking at, essentially, we are under ore commissioning, as Eben's talking about, and we're actually using the interim aggregate to conduct ore commissioning for that. In addition, the process plant. Right now, we are also undergoing ore commissioning in the process plant from the ball mill all the way down to our concentrate filtration circuit. And we are actually treating tailings. And to all of our surprise, let's see if I can get this to work, it actually works. I am more surprised than anybody. We're able to create and produce AGS concentrate from our tailings material. So if I can get this to work. So you guys can see something that excites me, maybe not excite the rest of you guys, but we've got beautiful bubbles and they're coming out. And you can see we did quite a lot of work even inside of our process plant, you know, refurbing our flotation cells as well. And this is a picture. It's been a while back, so it's way more filled now, but that is our concentrate that we're making every day. We have an excellent team who wants to be there, and we're definitely on the path to success. And the last, and then not least, our favorite circuit, the DMS. We're undergoing refurbishment as we speak, and we'll be ready to water and ore commission in December, as soon as Melissa and Isaac are ready. So in terms of, we did all this excellent work, what are we gonna do next? You know, there's always a saying that, I'm not gonna say the rest, but the mill loses it. So what are we gonna do to actually de-risk that? We know from previously, water quality was a huge issue in the mill. It really decreased our process efficiency. So what we are actually doing is we're designing a water treatment plant to be able to treat our water circuits as well as keeping them separate. The next one, we're making very high grade concentrate. There's not a lot of room for error. So now we're actually looking at an engineering view of what we can do to put meta-counting samplers to understand what we're producing and what we're putting in. And we're also implementing additional storage space into another megadome to be able to, you know, do grade control in our concentrate. And then last but not least, we want to bring this to a world-class asset. That means also world-class technology. We're going to be looking at process automation of our mill, starting with the flotation cell level control, and really be able to do analysis of our data and move forward. That's kind of what we're going to do, and I think we're going to succeed. So I'll turn it over to Eben.
I just want to say thank you to all of you for being here. Wow, you have quite the undertaking ahead of you. Congrats so far on working through those challenges, and I think we really wish you all the best as you continue to work through each of those challenges, and we look forward to seeing another world-class asset here in the province. I just got to say, like, just to echo something you said at the beginning, the fact that this is potentially like the only fluorspar mine in all of North America, and it is here in this province, it's quite an asset to the province. So congratulations to all of you. Keep your energy up.